So welcome everyone to this webinar, a part of the SPE Erbil Section webinar series. This webinar will explore the Pipesim Python Toolkit and deliver in collaboration with SLB. My name is Mohammed Subhi and I will be the moderator for this webinar. Today we have a special speaker from the Pipesim team. He holds a bachelor degree in applied mathematics and computer technologies, and he has more than 15 years of experience working with SLB and now working as Pipesim product analyst. He has also authored 4 SPE papers highlighting the production-related subjects. Welcome, Mr. Ruslan. We are happy to have you, and thank you for being here. And now the mic is yours.
Well, thank you for the invitation. Good afternoon, everyone. My name is Ruslan baiguzov. I'm Pipesim product analyst. And today I'm going to present you the fundamentals of Pipesim Python Toolkit. So I will switch off the camera and share my screen. And Mohammed, please let me know if we observe some issue with connectivity, because you know that today there was some issue in my location. So in case of the issue, I'll just repeat the material what I presented. Okay, so then let me stop my camera and share my screen. Hope you can see my screen. Could you please confirm it?
Yeah, it's clear.
Okay, great. So we will start with Pipesim Python. Okay, so the outline current presentation is the introduction. Then I will talk about architecture, show you some examples, then live demonstration and summary. So let's start from introduction. What is Python Toolkit? So first of all, Python Toolkit is a software development kit, and it includes several different modules. It uses the Python programming language, one of the most common scripting language, and SDK provides class and methods for working with Pipesim models. So the typical Pipesim task can be scripted and automated. The Python Toolkit is based on the Miniconda solution, which is part of the Anaconda distribution. And Python Toolkit is a component which is independent from user interface. So when you work with model using the Python Toolkit, you don't see immediately the update in the user interface. But it's at the same time, there is an advantage of this, so you don't need to keep the user interface open. So you just work with model as a separate element. So why Python Toolkit? What is the benefits? First of all, Python Toolkit allows you to create the model from scratch. So imagine that you have nothing. You have just the data from external data sources, and then you can create a workspace, add components, remove components if necessary. Once you created your network well, you may get to set parameters, define some parameters of these components. Then, of course, you can add the fluids and assign them to the components of your network. Once the model is created and fluids are assigned, you have everything to run the task. And the Python Toolkit supports different tasks in our user interface. Unfortunately, we do not cover 100% of the functionality, but most of the useful tasks, they are supported. And then later, if you want to analyze the result, of course, using the same methods, you can get the results, analyze them. And the Python Toolkit also supports additional options like import-export well, GIS map support. It means that you may create the Pipesim model with reference to GIS, capture elevations, move components and everything. And the most interesting thing for a lot of users is that Python Toolkit doesn't need a separate license. So if you use the Pipesim version 17 or more early version, you can use the Python Toolkit, like I said, for free, because the license is already included in the base license. So what do you need to do to work with Python Toolkit? So first of all, you need to install Pipesim, and then you need to install Python Toolkit. As you can see on this screenshot, it's not difficult. You just run installation and you see two options, Pipesim or Python Toolkit. Just install them one by one. And I added here a good reference about the recommended settings, because during the Python Toolkit installation, you may install it with additional options, but our recommendation is to install with default settings. Python is the really popular tool or program language, which can be installed with different software or just a separate, just a single Python as a part of the IDE or whatever. And it's possible to observe some conflict between the Python versions from the different components. So in case to do everything smoothly, we recommend to install Python Toolkit with default settings. And if you are advanced user, then of course you can manage your environment and do it whatever you want. So once the Python Toolkit is installed, it doesn't require really a lot of steps, just next, and then you've got everything on your PC. So once it's installed, you need to work with Python Toolkit. By default, we do not distribute any development kit. And the reason of it, because every user like something what they worked before. And the Python Toolkit is supported by many of the existing IDE. So you may install, or maybe you already have something installed on your machine. So then you can use the PyCharm, you can use the VS Code, VS Codium, Visual Studio, whatever. Even you can do it in Notepad++. But in the installation folder, we deliver VS Codium. It's a version free for delivery, so we can distribute it as an open source version of VS Code, the most popular. Of course, we recommend to use VS Code for most of users if you have no own preference and if you have no access to internet. But we observe that some of our clients doesn't have access to the internet on their location because of the security reason. In this case, of course, we distribute the VS Codium, so you can install this VS Codium and configure and use it on your machine. So it's up to you what the IDE is to use. I think that now we can move on to the next part, is the architecture. So what is the Pipesim Python Toolkit? As I already told you, that the PTK is the distribution kit, and PTK is based on the Conda. I mean the Conda, the engine of Anaconda. So once you install the Python Toolkit, you've got the Conda engine with package manager. And by default, we provide some set of the packages, the most popular one, which doesn't require a separate license for distribution. The key components I mentioned here on this slide. So you might see that we have the 6GIL and Manta. This is proprietary packages from SLB. So all classes and modules are necessary to work with Python, with Pipesim, are in these packages. So they will be installed automatically. In addition, we install Excel Wings. It's the model for work with Excel, and the Pandas, the most popular package for tabular data processing. And you may see also several packages, but this is the key packages, what I needed to work with Pipesim. And if you like do some external things, like you want to work with neural networks, or you want to work with some complex math or whatever, you can download it without any problem using Conda packages. If you don't like the Conda, the PEEP package manager is also supported. So if something is not available in the Conda channels, it can be downloaded from the PEEP channels. So everything is installed, and you want to know how it works. You can see this image with two parts. On the left part, you may see the structure of the Pipesim application. So let me just see if I can add the pointer here. So by default, we have the Pipesim user interface. It links with domain model. So it's all of these two rectangles are part of the Pipesim user interface. So you create the model and user interface, you save it, you manage it, and then you want to run the simulation. Once you click the run simulation, the user interface creates a file, send them to engine, engine calculates everything, and turns it back to Pipesim. So this is the architecture of our application. Of course, we have several additional layers. They are hidden in the UI, but the key elements are here. Comparing to this architecture, the architecture of the Python toolkit is different. So we still use the same engine to calculate, but we don't have, of course, user interface because we work this model. And for the main model, to operate, to manage this domain model, we need some layer. And this layer called is Web API. It means that when you run the session of the Python toolkit, Python scripts automatically run the web session and create connection to the domain model. And then on the other side of this, we have the clients, which are hidden inside the 6GIL and Manta packages. And these clients connect to web session and allows you to send them information to web server and ask him to update the model or run execution, or in general words, you may manage this model using this connection. And of course, these models are delivered on the base of the Python. So you have a Python, you have a models, you have the connection with web API, web service, work with domain model, and then once everything is ready and you run simulation, the engine is used to run the simulation. And in addition to your connection, of course, you can connect your solution with external data source. As an example, we, as many engineers, like to use Excel. So for Excel, to connect with Excel, you need some model, and that's why we provide these Excel links. So using Excel links and VBA, we can connect with Excel. There are two types of connection with Excel, because Excel is the most useful component. So we, of course, support connection with Excel by default, and there are two types of connection. One type is when you open access to Excel as a data storage. So you just connect to Excel, send some information, get some information, but the key component here is your script. So your script works with Excel as a storage. But another one option, which is supported by our solution, is to use Excel as an interface for your solution. I will show you example later. So, but now I want to tell you a few words about the structure. So Excel represents a user interface. It means that you have to run PTK from Excel, and you expect to get the results in this Excel. For this purpose, we need at least two buttons. Button one is the connect with Python script. It means that you open this book, you click connect, and at the same time, Pipesim runs the server. So it runs server script and establish connection with server. Once the connection is established, you can send some command to manage your model. Maybe you want to set parameters, maybe you want to run simulation or extract results, and then we use another one button which send the command through the client to the port what we already established, and then this server will automatically process your request based on your command and manage your model. So this is in general words. Of course, you can see a lot of functions here, a lot of code, like this handler message or main components or whatever thing. So this image is described with details in our help. Later, I will show you where you can find help and where you can read it carefully. But in general, you just need to know that we have two approaches: when the Excel is user interface or when Excel is a data source. And once you work with Excel as user interface, you need elements to control the process. Run simulation, establish connection first of all, and then run simulation, get results. So this is the key element of the architecture. And the place where you can find more detail is the documentation. Once you install Pipesim, not Python toolkit, Pipesim is enough for it. Once you install Pipesim, you get access to the Pipesim Python toolkit documentation. In this documentation, you have a lot of things like overview, the main functionalities, introduction, the key changes between the version, and then quick start section. This is the most valuable thing if you are not experienced user of the Python toolkit. In this section, you may find guide whereby step by step you can do some basic things. I think it's a time to go to examples and see what we have in our distribute in this installation kit. So once Pipesim is installed, you may get access to many different examples. You may split these examples by two groups. First group is the code examples, and they are delivered in the Pipesim. For instance, for version 23, it will be 23, then developer tools, Python toolkit, and examples. And here you may find a lot of code examples. So I may say that for 90% of the methods available in Python toolkit, you may find special files. So for instance, I want to know how to work with black oil model. Then you have this get set black oil. You will open this example and see the key elements you need to do to get the black oil information or set black oil information. Or another one example, I want to add the well, and then you can also find how to add the well or another thing. So there are a lot of different examples, but again, this is the code example to help you to understand what is the syntaxes, what is the logic, and what you should expect, what type of the data you should expect from this or another one method. But at the same time, we have another group of examples, and we call them solution examples. They are placed a little bit in different, but at the same installation folder, but you should go to the case studies, and then you see a lot of different case studies, and one of the Python toolkit, and you have a group of ready solutions. It means that you can open this, investigate it, of course, as an example, but it's a ready solution for some task. Later, I will show you what we can do with it. So, code example. This is the typical code example. Get set value. So, you may see that, first of all, we need to load some libraries. Once the libraries are loaded, we can open the model. And since the name of this example is get set, I expect to see something with get value or set value. And then, of course, I see here, we get the choke. We get value from this choke, and what the parameter we needed is the bin size. And once you run the script, you will have the report from the script that bin size of this choke is this value. And at the same time, I want to know how to set this. And here there is a code with description how to set it. So we create a new value, and we use the same model to set the value for element choke, this bin size, and then new value. And to make sure that we set it correctly, after the set is completed, we request the same value again. So we want to get the value and then report this information. So you open example, you don't know how to work with this method, you just open example, run it, see how it works, then go inside and see what functions were used, and what the syntax is. And to be honest, with my experience, sometimes, time to time, I use this example to check how to do it properly, because you cannot remember everything, all details, but they're really useful. This is the code example. And another one, as I told you, is the solution example. So the most of solution examples, not all, but 90%, they have the following structure. So first of all, we have the these components path definitions. So we have the link path to the Python directory. If you install several Python toolkit versions, but we support it, so you may use Python toolkit and the Pipesim 21, 2, 3 on the next one. So if you install them, you can select what the Python toolkit is needed for you, because it depends on the selected version, you will use the Pipesim of this version. So if you use Python toolkit 2022, you will work with model 22 and you will save your model in the version 22. Okay, so we selected this and we have the name of the model. Then we do the connection with script, open the model, get some results, run simulation, and we have something. So this is the common template of all solution examples. You may investigate them, and I will show what we have later. So examples. We have different examples of this solution. Some of them are grouped as a manager, and some of them are very specific. If you're familiar with Pipesim interface, we have managers, some managers in user interface, like flow manager, fluid manager, and others. But not everything is covered. So I used the opportunity to add something using the Python toolkit in our installation kit, and I added few examples to help user to manage huge model, because when you work with huge model, you need these managers. You cannot do everything, changing the values one by one in each component. And this is a good example for choke manager. So for instance, you've got the model, huge one, more than 100 wells, maybe 500 wells, and each well has own choke, and you need to adjust its choke based on the operational data. You can do it one by one, or you can use this ready solution just to connect the model, extract the data from the model, and then this solution will automatically fill this table, and then you will see the name of the component, status of this component, bin size, and some additional settings. And as you can see, this follows the user interface of Pipesim choke, the same name, bin size, or whatever. So, of course, not all parameters are mentioned here. These are the key parameters, but it can be extended easily. This is one of the example of solution. So you can do it yourself using the Python toolkit, but at the same time, it's already there as an example. Another one thing with Spot Report Manager. Spot Report Manager, as you can see on this window, has different options, and most of them are just click options, enable or disable. And if you have many spot reports for some purpose, for instance, for reporting phase envelope or whatever, you need to manage it, and the same is available in the Excel. Again, the Excel represents user interface. Another one example, VFP charts. This solution is not available in the installation kit, but it's available by request in SLB support team. We have internal channels where our users or experienced users develop own script, and they mark them to be ready to share with our users outside of SLB, and users may request something. So my recommendation is, if you need to develop something, you may try to contact our support engineer and ask if something is already developed and can be shared with users. But anyway, this is the example how Python toolkit can be used to solve certain tasks. Pipesim supports functionality to create VFP table for a reservoir application like the Intersect or Eclipse or whatever. We export VFP table as a text document, but at the same time, sometimes you need just to do the visual verification of the data we exported. Unfortunately, Pipesim is not delivered to support this functionality, so it's not implemented yet, maybe sometimes later. You can do it using third-party tool. Since I'm SLB guy, so I can recommend you the Petrel, or we delivered the example where you can just open this and show the results using the Python. So this solution was developed based on the Python modulus, which extracts information from text file and shows them as a set of the charts. So I think that's all for introduction, and it's a time to move on to demo. So let me close my presentation. You should see Pipesim window. Could you please confirm that you see the Pipesim window?
Yes, we have.
Okay, great. So we can move on to this. So first of all, I want to open some model, and I go to case study. We have different case studies here. I'm going to open the model. I think that the simple one is fine. So for instance, we have this one, and I will copy the path to this model because I will use it later. So the path of the case study model. Okay, this is the simple model we have in Pipesim, and I want to show you how to work with this model using the Python toolkit. So I will adjust slightly the size of the screen to get access to VS Code. So VS Code is installed. In addition, I installed the Jupyter Notebook, so I can work with code with Jupyter. And if I want to work with Python Toolkit, first of all, I need to load library. As I told you, in all examples we have, first of all, we need to load library. And then the basic things is to load 6gil. I told you that this is the main model of Pipesim Python Toolkit, 6gil Pipesim import model. And then I need to import, so this model is used to work with model itself, but I need a lot of constants and definitions. And for this case, I have to use the definitions from 6gil definitions. I can import, and then I can import, of course, only what I need, like a constants, or in our case, I can import everything. Let me just import everything. Okay. And now I want to connect to the model, and then I use the model open, and then I need to specify the path of the Pipesim model. So I will use this, and now we can see why I used this example, copied this example, because I put the path to this model. I want to open it, and let me just run it. So you may see there is a process. So as I told you, once I connect to the model, Pipesim Python Toolkit runs web service and establishes the connection between the server and client in the Python environment. So connection is established, and I can work with the model. So first of all, let's see what we know about the model, the basic things. Model about. I've got the basic description of this model. Some additional information about web IP version, we don't need it. The Python Toolkit, okay, we use 22.1, then the name of the file and unit system. We can establish the connection with different unit system. By default, we support 3, a Pipesim field, I mean this empirical unit system, metric unit system, and C unit system. So it can be specified during the connection. If I set another one parameters here, I can say units, and then I have these options, but I'm not going to do it right now. Okay, so we have the model, and we connect it to the model, and I want to know what component do I have in this model. I want to investigate this model. How can I do it? I can find element, and since I don't know anything about this model, I want to find everything what I have in this model. I use this model find all and got a lot of information. So these are the list of the components what we have in the model. Too many things. I need to be more specific. Let's check what the flow line I have. The model find all components with model components flow line. Okay, and I expect to get the results of flow lines names. I can see that I have several flow lines. I have all the names. Let's check with user interface that we are working with correct model. So 1, 2, 3. Okay, I can do this one. Flow lines, and then flow lines again. Wait, no. And then the line of the flow line. Okay, we have 8 flow lines. And the names of the flow lines, let's check this. Okay, we have the 8 flow lines. It seems that the names are correct. So we established the connection with correct model. I got the name of the flow lines. I want to get some value from these flow lines. Let's try to get the value. If I want to get all values, I don't know what I need. I just want to see what can I do with it. I use the method get values and then specify what component should it be. Since we've already requested the list of the flow lines, let's get the information from flow line 1. Okay, I see I have a big dictionary with a lot of information, like is it flipped, or what is it, a riser? No, it's not a riser. What's the depth, or ambient temperature, or whatever. There are a lot of things here. I don't need them all. It's too much for me. Instead of them, let me try to get some specific value. So instead of get values, I don't need all of them. Again, it's useful when you work with model. You don't know what the name of the parameter. You don't want to use the help for some reasons. You want to investigate just the model. Then, of course, you can get everything and just go through it and see what is necessary for you. Or maybe you change something in the model. It's the good way to see what the parameter is used. You just use the model, set the values, open it through Python Toolkit, get all parameters of flow line, then change model slightly in user interface, save the model again, open another session and compare between the two sessions. And you will see what parameter was changed, and then you will know what is responsible for this parameter. It's another option. But in my case, I don't want to do it. I just want to get from the model flow line 1, I want to get the same parameter. Let me use the parameters class. The parameters class has a lot of subclasses, and one of them flow line, because I want to get the parameter from flow line. And I want to select one of them. There are a lot of the parameters here. And I think that since it's a flow line, the base things for flow line is diameter. So let me try. No, it's not inner diameter. Yes, inner diameter. I want to get the information about the inner diameter. I run it, and I get that the inner diameter for flow line 1 is 6.065. Let's check it. So we have the flow line FL1. We open it, and the diameter, yes, the diameter is correct. Okay. Now what we can do, we can set this value. For instance, we want to change this value, and then I will use the model set value. I will set the value for the same flow line 1. I will use the parameters flow line in the diameter, and let's use the value 10 inches. It's a huge one. Set the value. But how can I check if the value is correct? So I can request the value again and see, is it updated in the current version? Yes, it's updated in the current version. Okay, but how can I make sure that it's fine for the model? So before I leave this section, I need to save this model. And for this, I will use the model save method. Okay, I will save this model as C10 model. Save the model. Okay, the model is saved. So now I need to open this model. Of course, I can just navigate in the Explorer and the Windows and find this model, but there is another way to open the model. I use the model class method open model in UI, and then path, send then path of my model, and then I will wait. So you can see that Pipesim PTK initiates the process to run Pipesim with the model, and model is opened. Okay, the name is changed, my new model, and I expect the flow line should be 10. Let me double check. Yes, the flow line in the diameter is 10. It means that we successfully updated the parameter for our model and saved it. Okay, that's fine. Let's do something else. So I told you that there is a method to get the values from the model. But what if we want to know the units of these values? So then we can try to use, by the way, the session is not closed. I haven't stopped working with the model. Model was just saved, so I can continue to work with it. If I want to close it properly and release all memory of my session, then I need to use the close method. I'm not going to do it right now. I'm going to continue to work with it. So I need to get the information again about all parameters, but this time I need to get units. Okay, get values as necessary at the end. Okay, then what we are going to do, let's use another one, flow line 2, for instance. FL2, and that will be the context. I need to check what the parameters are. So first I need to specify the context. In my case, it's just the name of the flow line. Some parameters, I'm not going to specify some parameters. I can do, of course, if I know them, but I want to do everything. I want to get everything. And then the last argument here is the show units and use the bool value to show them. Okay, let me just use context here. Okay, to work with flow line 2 and show units true. Okay, I have this big output, and let me open them in the text editor. Okay, so what I have, I have the dictionary, flow line, okay, the list of the parameters. And then in this dictionary, we should have another key argument, unit. Okay, so we have the unit, and then we have the units for each parameter. So, for example, let's check some of them with value. I think the inner diameter is fine. Which one we can use? Oh, roughness. Okay, we can close it. The information we've sent, let me just save it as a data. Okay, data, FL2, parameters, flow line, roughness. So this is the value, roughness. And what if I want to use? So I need to pass somewhere. Let me just double check. Okay. If I don't use this one, but these output. So units not here, and if I set this one unit, okay, I have the units. And if I use parameters, flow line, roughness, from the same data set, I've got the units of this roughness. Okay. Yeah. So this is the example how you can get the information from the model, and you can continue playing with it, of course, but I think that we need to move on to the next step and see what else we can do with the model. So imagine that we created the model from scratch, or we opened the existing model, we changed everything. Okay, why do we need to do it? First of all, we want to get the new results. We need to run the simulation. And for this purpose, PTK has the class tasks. So if we run model and tasks, we have a list of supported tasks, the Pipesim. We have a network. So I think that it's logical, will be logical to run the network simulation. We have the network simulation. And then we have the list of the methods, and we need to use this run. Okay, and the results should be in the file model results. Let me run the simulation. So simulation run takes a time because I didn't specify any parameters in these brackets. If I want to run it quickly, I can specify certain parameters. So for instance, what profile variable or what system variable I want to receive. Because if we pass the empty parameters, or sorry, if we do not specify the parameters, Pipesim will run simulation and extract everything what is possible from this model. And of course, it takes more time than extract just specified parameters. But anyway, we've got the result. In the results, we have different options. Let me show you the messages. Oh, this is the messages, and the messages are similar as what you have when you run the simulation. Imagine that you have the network, you run the simulation, and you can see the engine console. So the same logic is here, and you can get the messages from the Python toolkit, but we don't need them by default. What we need to get is the data. So in the results, as I told you, you have the profile, system variables, and some system are covered by node special structures and all that. Let's see what we have in the system. In the result system, we have a lot of information. So first of all, we have the dictionary. The key of the dictionary is the parameter name, and then as an argument, we have another one dictionary inside, order dictionary with elements. So for each of the component, we can get the value. Okay, let's try to get something for, what could it be? I think we can get something for pressure or system pressure loss. We want to know what's the pressure loss. Explanatory system pressure loss. Then we have the list of the components. So we have the unit PSI for pressure loss parameter. And then we have the list of the component, gas cells, well, oil cells, and everything. So the same as you see here on the node branch results tab, but for the branches, of course, like system pressure loss. gas cells, 71. So it should be close to this one, 69 here. Okay, so the value of close, maybe the model. Yeah, this is the original model where I didn't change the flow line in the diameter, but since I changed the flow line diameter is my model, so the Pipesim distributed slightly different the flow in the model, and then I have slightly different result. Okay, so we've got the results. What else we can get here? So I told you that this is a system. We can get the profile results. Results, profile, and these results are slightly different because in the system, the key element was the name of the variable. But in the profiles, the key is the component, like source. If I request the source, I got the details for this source. I have the parameter name, and I have the list of all these things. Okay. This looks interesting, but it's not really user-friendly to read this information. Of course, we can go to the text editor and find something from here, but I want to see it as a good table format. So what can I do? I told you that we deliver in our installation kit pandas as a library. So we need to import pandas. Import pandas as PD. We'll call that PD. And then we have these results. And I can use the PD data frame results file. Okay, now it's more useful. Now I can see what the structure. So we have the name of the component as the header of our table. Then we have the list of the parameters, and for each of them, we have the data set. Now it's useful. So for source, for branch called source, we have the elevation. This is the distance of our source. So we can see here, this is a branch of source, which has the source itself and flow line. We can find everything here. Source, okay, the values are here, and the elevation -20, 2.510, and the same we expect here. We have everything here, and then we have other parameters for this source. So everything is here. Okay, so this is the way how we can create a model or open existing model, change values, run simulation, save results. I told you that if you run simulation with empty brackets by default, you will calculate a lot of different things. And let's see how quick it was. So Python Toolkit spends 27 seconds to get these results. And let me show you another one example. So imagine that we know what we need to get, and we want to specify. I don't need all of these profiles, profile variables. I want some certain profile variables. For example, profile variables. And then I say what profile variables? Pressure. I need only the pressure distribution in the profiles. I don't need everything else. Okay. System variables. Again, I need to pass the list of the variables. System variables. Okay, we will use the name of the class system variables, and then see what is available here. And let's use head. And we'll use the results too to get the result and run simulation. The previous one took 27 seconds. I expect that this one will be much faster. Let's compare. Okay, now it takes 7 seconds. And this is the difference in the simulation. Okay, and now we have these results. Let's see what we have in this one. File. Okay, we can see how many components we have here. So in the keys, we have the same names. But if we take one of them, like gas cells, see how many parameters do we have inside? We have only two, pressure and branch equipment. So we can use this one. And if I need to close this section, of course, once I'm done with everything, I need to release my memory and release my resources, and I need to use model close to close it. Once I used it, I cannot continue to work with model anymore because the session is broken. Sources are released. So that's all what I wanted to show you as a live demo presentation. And let me just finish my main presentation with the slides. I will run the last slide of my presentation, the summary. So if you want to work with Python Toolkit to automate Pipesim routine, run it, use it as an engine, you can Of course, you have to install the Pipesim and Python Toolkit. Then you can install the IDE, whatever you like. We recommend use VS Code. This coding is delivered installation package, but you can use whatever you want. Then my suggestion is to start from reading quick start guide. There are a lot of good things there. We have a lot of examples. Please check them. You will find more interesting information. And if you have a question, you may contact us with support. We are here to help you with Python Toolkit. And try to automate your routine. Do not do it manually. Use the power of Python Toolkit. So that's all from my side. Thank you very much for your attention, and I'm open to answer your questions.
So thank you very much, Mr. Ruslan. If anyone have a question, please don't hesitate to write your question in the chat box, or you can raise your hand in order to ask Mr. Ruslan.
Hello, good afternoon. My name is Luis, and I do have a question.
Yes, please go ahead.
Okay. So, what I would like to see is that how can we download for instance, the ESP curves for an nodal analysis?
ESP curves in nodal analysis.
Yeah, ESP performance curves.
Some curves are available after the simulation. In this, so it's a really complex question, by the way, because ESP curves is supported in one of the last versions, and we can get them. I think that we can get them after the simulation. Need to check it. Let me have a look. So we have a special structure in the results. I will try to find the example right now. Okay.
Okay.
Oh, I think that because it's not a question that I can easily answer, I need the time to prepare the scripts. Let me just then add a note about your question and then prepare and share with you the answer. Okay. I need to double check if we report. I think that we reported after the simulation the results. Just need to double check it.
Yeah, thank you, Ruslan.
If we have another question, I
Yeah.
suggest to move it, and then I will answer it, of course.
Okay, thank you. Yeah, usually we want to know if the pump is in downtrust or uptrust condition. So that's the reason why I want to know by using this ESP performance curve what is the actual status of my pump.
We have another one question, I think.
Hello, hi. I have a question regarding if it will be possible to extract the fluid information, like compositional fluid, the phase envelope, and all the stuff. Density of the fluid using the Python toolkit, or because you can create a composition fluid, but you don't really get the information as far as I know. Is it possible in a newer version maybe or something?
Extract the composition of the fluid itself, it's like, possible, same as create. So once you created the you see everything. But what you need to get the properties of this fluid in the certain conditions. And this thing is not supported by Python Toolkit. It's supported by Pipesim also, only. So we have a special tool called spot report. You can put this spot report at any place where you want at the network. Once you run the simulation, you can open. I can show you, by the way. You can open and see result, but it's not supported by Python toolkit. Unfortunately, this data structure not passed. Check my screen.
So you recommend maybe using the spot report probably.
Oh, that's the thing. It's not supported by Python toolkit. This is the disadvantage. So like this one, when you have the spot report, you connect it with model, and you say that I want to have the phase envelope and fluid details, fluid properties and everything, and you run the simulation. And you will have a separate tab for details. So this auxiliary result, you have the flow map, you have phase envelope and everything, but this is available only in the user interface because it's a separate thing. It's not covered by Python toolkit, unfortunately.
Okay.
But using the Python toolkit, you can get using Python toolkit. You can open your fluid. You can get the information about your components. So this, for example, this list of the components, you can get what the list of the components, what the properties of these components. And if you have some user-defined, you can get the basic information of this user-defined component. That's all. But you cannot get the simulation results because the separate library is used to get it. It's
understood. Okay, thank you.
Do we have other questions?
So we have a question from Adi in the chat box. He said, why using Python for simulation rather than simulate directly in Pipesim?
Good question. First of all, it's automation. So imagine I have a network with ESP, for instance, with 100 ESP wells with ESP. I want to run something. I want to run the simulation. And I need to do the correction for all of them and run it. Oh, I want to match them, for instance. I've got the new information about the performance of well, and I need to match them. And I decide to use some coefficients to match them. So we have the head coefficient, or I can use the friction factor to understand what I can do manually in the user interface. I just open each well one by one, run PT profile, see the result, compare it with data I have, adjust slightly, run again, get the result, close the one well, go to another one well. And if you measure how many seconds I spent opening this, closing this, copy data between the Excel and the Pipesim interface and everything, you'll be surprised that you spend more than half of your time doing these things. But if you have the Excel with a predefined script, you can do it easily, just run in the cycle. So Pipesim will do everything. Do Python toolkit using the script will cover everything without any delay. You just need to run it. You can go to take a coffee and come back and see what the results are. But of course, if you need to do it once with 10 wells, it's not worth developing your script. But if you do it on the daily basis, it's worth developing the script and automating routine.
Mr. Luis, please go ahead.
Okay, thank you. So I have another question. For instance, when I am doing the fluid calibration, right? Usually I use the system analysis task in the user interface, right?
Mm-hmm.
And I write many pressures to see the behavior of the oil viscosity. So my question is there any way to download the oil viscosity behavior by pressure by using the Python toolkit?
Okay, so let's open any case study and make sure that I understand your question correctly. So let's take the oil well. So I will use PT profile instead of the system because it's easy to configure. Let me check. It works fine. Okay, I've got some results, and then I have a fluid. So in the completion, I can try to find what I can override. So for instance, the GR, let me have look what the fluid is. So I think they use a heavy oil with GR 200, and then I will use 200 around the simulation. And I've got some results. So let's change the view to show and then see what viscosity, for example. So around the flow on gas viscosity, oil viscosity is an example. And I have these results depending on the parameter I run. And they are not the same. We see a difference. By the way, we go here, we can use the same total distance, and then flowing. We see that the values are changed depends on the parameter. And that's what I've done right now. These things you can repeat easily in Python Toolkit. You just get the results, run simulation, get the results. You just adjust the input parameters and say that, okay, my new data set is following. It will run automatically and report you the view. All this data available.
Okay, got it. Thank you.
So as of now, I believe there are no questions. I would like to express gratitude to Mr. Ruslan for delivering this webinar. Your efforts is truly appreciated. Thank you so much.
Thank you very much. I will check the question with course. At least I see that we have ASP course variable, means that we plan to support it. Need to check what version is supported properly, and then I will provide a feedback about this question. Okay, but then I also use the help to use. So my suggestion is use the help to investigate the Python Toolkit.
Okay, that's great.
Okay, thank you.
Okay, goodbye. Thank you so much.
Goodbye.